welcome to another episode of AI for the Humanities. I'm Meghan McInnis-Domínguez, Associate Professor of Spanish at the University of Delaware. Today, we're exploring the essential vocabulary of generative AI, a topic that's becoming increasingly important for humanities scholars and educators. As artificial intelligence continues to evolve and intersect with our fields, it's vital that we understand the language and concepts behind these technologies. Whether you're exploring AI-assisted research methods, considering integrating AI tools into your teaching, or simply trying to keep up with the latest developments, having a solid grasp of AI terminology is key. In this episode, we'll break down some of the most important terms and concepts in generative AI, starting from the basic building blocks and moving up to more complex ideas. We'll cover everything from natural language processing and neural networks, as well as machine learning, to the differences between large language models, AI assistants, and chatbots. We'll also touch on the practical distinctions between APIs and forward-facing products, as well as open source versus closed source models. Our goal is to demystify these terms and show how they relate to our work in the humanities. By the end of this episode, you'll have a clearer understanding of the AI landscape and be better equipped to engage with these technologies in your research and teaching. So, let's dive in and start building our AI vocabulary. We're going to begin with neural networks. Neural networks are a fundamental concept in AI, inspired by the structure and function of the human brain. They consist of interconnected nodes, or artificial neurons, which are organized in layers. Each connection between nodes has a weight that adjusts as the network learns from data. Neural networks can identify complex patterns and relationships in data, making them powerful tools for various AI applications. They're used for tasks like image recognition, language translation, and predictive analytics by progressively adjusting weights through training, allowing them to make increasingly accurate predictions or classifications. These models excel at handling complex, nonlinear data relationships, making them fundamental to many AI applications, including deep learning and generative AI tools. Some key components are the input layer, which receives initial data, hidden layers, which process and transform data through multiple interconnected nodes. There's the output layer as well, which produces the final result, as well as weights and biases, adjustable parameters that the network learns during training. We also have activation functions which determine the output of a neuron, given an input. There are other things to consider, like interpretability. Neural networks can be black boxes, making it crucial to critically evaluate their outputs. It's also important to consider how to integrate AI insights with traditional humanities methodologies. We have to be careful of bias and representation, because neural networks can perpetuate biases present in their training data. It's also very important to consider issues of representation and inclusivity in AI-assisted research. It allows for interdisciplinary collaboration because understanding neural networks may require collaboration with computer scientists or data scientists. This gives an opportunity for humanities scholars to contribute to the ethical development of AI technologies. Neural networks also allow us to investigate new research questions, enabling new types of questions and analysis in humanities research, as well as the opportunity to explore the intersection of technology and human culture in novel ways. Neural networks represent a powerful tool for humanities research, offering new ways to analyze texts, images, and cultural data at scale. While they present exciting opportunities for discovery and analysis, they also require critical engagement from humanities scholars to ensure their ethical and effective use in studying human culture and expression. Now we'll move on to natural language processing, which is a branch of AI focused on enabling computers to understand, interpret, and generate human language. NLP combines computational linguistics, or rule-based modeling of human language, with statistical machine learning and deep learning models. This field bridges the gap between human communication and computer understanding. There are some key components and techniques. First of all, there's tokenization, which is breaking text into manageable units such as words, subwords, or characters. There's also part of speech tagging, which is identifying grammatical components of sentences. Next is named entity recognition, which is identifying and classifying named entities like people, places, and organizations. There's also sentiment analysis, determining the emotional tone of text, and syntactic parsing, which is analyzing the grammatical structure of sentences, and semantic analysis, understanding the meaning and context of language. Machine translation automatically translates text from one language to another. There's also text summarization, which creates concise summaries of longer texts. The relevance to the humanities is that natural language processing is crucial for computational analysis of texts in literature, history, and cultural studies. It enables large-scale text analysis, automated translation of ancient texts, sentiment analysis in historical documents, and the study of language evolution over time. We will now move on to machine learning, which I mentioned before. The definition of machine learning is that it's a subset of AI that focuses on creating systems that can learn from and make decisions based on data. Instead of following explicitly programmed instructions, ML algorithms build a model based on sample data, known as training data, to make predictions or decisions without being explicitly programmed to do so. There are key types of machine learning. There's supervised learning, where the algorithm learns from labeled training data. It's used for classification and regression tasks. An example in the humanities would be classifying texts by genre or author based on pre-categorized examples. Next is unsupervised learning, where the algorithm finds patterns in unlabeled data. It's used for clustering and association tasks. An example in the humanities would be discovering themes in a large corpus of texts without predefined categories. Next up is reinforcement learning, where the algorithm learns through interaction with an environment. It's used for decision-making tasks. An example in the humanities would be developing interactive narrative systems that adapt to user choices. Other key concepts are feature extraction, which is identifying relevant attributes of data, model selection, choosing from appropriate algorithms for a given task, training and testing, which is using separate data sets to teach the model and evaluate its performance, as well as overfitting and underfitting, which is balancing the model's ability to fit the training data and generalize to new data. Other advanced ML concepts are ensemble methods, which is combining multiple models for better performance. Transfer learning, which is applying knowledge from one task to another. Few-shot learning, which is learning from a small number of examples. And here, again, the relevance to the humanities is that ML can be applied to analyze patterns in cultural evolution, attribute authorship, develop recommendation systems for digital archives, and even assist in the restoration of artworks or ancient texts. Now we'll move on to generative AI. Generative AI refers to artificial intelligence systems capable of creating new content, including text, images, audio, and even code. These systems learn patterns from existing data and use this knowledge to generate new original content that mimics the style, structure, or characteristics of the training data. Some key concepts are generative models, AI architectures designed to create new data, latent space, which is a compressed representation of the training data from which new content is generated. There are also variational autoencoders, which is a type of generative model that learns to encode and decode data. We also have generative adversarial networks, which is a system of two neural networks contesting with each other to improve the quality of generated content. As we mentioned earlier, there are various types of generative AI, like text generation, which is creating written content, like the GPT models. Image generation, which produces new images, like DALL-E, Midjourney, Flux, and more. There's music generation, which is the composing of musical pieces, video generation, which creates video content from text descriptions or other inputs. Relevance to the humanities is that generative AI can be used to create pastiches of literary styles, generative visual representations of historical scenes. It can compose music in the style of specific composers, or even help in reconstructing damaged artworks or texts. Now we're going to study the differences between large language models, AI assistants, and chatbots. While completing the sentence is a fundamental mechanism in modern AI language technologies, especially LLMs, it's an oversimplification to describe all these systems this way. Chatbots and AI assistants, in particular, often incorporate additional technologies and methodologies that extend well beyond this basic functionality. Understanding these nuances is crucial for humanities scholars looking to effectively leverage these tools in their research and teaching. First, we're going to talk about large language models. LLMs are the foundation of many AI technologies, including AI assistants. They're trained on vast amounts of text data and excel in language understanding and generation. Their capabilities include natural language processing and generation, text completion and prediction, question answering based on training data, language translation, summarization of texts, and code generation and understanding. Some of their modalities also include they're primarily text-based. Some advanced LLMs can process and generate text based on image inputs. Examples of LLMs include ChatGPT 4.0, Claude 3.5 Sonnet, Llama 3.1, and Gemini Pro. The strengths of large language models are vast. To begin with, there's core language processing. LLMs are designed specifically for understanding and generating human language. They excel in tasks like text generation, summarization, and translation, making them powerful tools for research and creative writing. They're flexible. LLMs can be fine-tuned for specific applications, allowing researchers to adapt them to niche topics within the humanities. This adaptability can lead to innovative uses in specialized fields. They also have creative potential. LLMs can generate original content such as poetry, stories, or academic papers, which can inspire students and faculty in their creative endeavors. We can also talk about their research capabilities. They can analyze large volumes of text quickly, making them valuable for literature reviews, historical analysis, and comparative studies. Now we're going to talk about AI assistants. AI assistants are applications built on top of LLMs, often with additional features and integrations to enhance their functionality and user experience. Their capabilities include all language capabilities of their underlying LLMs, real-time information retrieval for some, integration with specific ecosystems or applications, task automation, personalized responses based on user data or preferences, and multimodal interactions depending on the assistant. There are various modalities. For example, there's text-based interactions, voice interactions for some, image analysis and generation for some as well, and document analysis and processing. Some examples of AI assistants are Perplexity and Microsoft Copilot. They build upon other LLM technology, such as ChatGPT 4.0. Strength of AI assistants, well, they're user-friendly. AI assistants are often designed with intuitive interfaces that make them accessible to users without technical expertise. This can lower the barrier to entry for educators and students new to AI. They also offer real-time information access. Many AI assistants can pull in real-time data from the internet, providing up-to-date information that can be crucial for research and teaching. There's also task automation. AI assistants can automate routine tasks like scheduling, document formatting, freeing up time for educators to focus on teaching and research. They also integrate with existing tools. AI assistants often integrate seamlessly with popular software suites like Microsoft Office, which is used by Copilot, enhancing productivity and facilitating collaboration. We're now going to move on to chatbots. A chatbot is a computer program designed to simulate human conversations through text or voice interactions. Chatbots can range from simple rule-based systems to more advanced AI-powered conversational agents. Some key characteristics of chatbots include that they're primarily designed for direct interaction with users, and they can be rule-based, following pre-programmed responses, or AI-powered, using natural language processing and machine learning techniques. They're often specialized for specific domains or tasks like customer service or information retrieval. They may or may not use large language models, depending on their complexity. Examples range from simple customer service bots to more advanced conversational AI systems. Some general purpose chatbots include Siri, which is a virtual assistant that can answer questions, set reminders, and perform basic tasks. There's also Alexa. This is a voice-activated assistant for smart home devices, which is capable of voice interaction, music playback, making to-do lists, setting alarms, and providing weather, traffic, and other real-time information. There's also the Google Assistant, which is an AI-powered assistant, which offers voice commands, voice searching, and voice-activated device control. There's also Microsoft's Xeos, which is an advanced conversational AI system, which is known for its ability to engage in more natural human-like conversations. It's specialized in academic research chatbots include Iris AI, which is an AI-powered science assistant, which helps researchers find relevant scientific papers and summarize research. There's Ada by Adaptilab, which is a chatbot designed to assist with academic writing and research. It offers grammar checking, citation assistance, and research suggestions. There's also Quillbot. While it's primarily a paraphrasing tool, it includes a chatbot interface for writing assistance, which can be useful for rephrasing texts and improving writing style. There are also educational chatbots like Duolingo's language chatbots, which is used for conversation, for language learning, to allow learners to practice conversations in a safe, simulated environment. Some writing and storytelling chatbots include Botnik, which is a collaborative writing tool that uses AI to generate creative content. It can be used for experimental literature and studying AI and creative processes. Advanced AI chatbots include ChatGPT, based on the GPT generative pre-trained transformer model. It's capable of natural language understanding and generation, and can engage in complex dialogues, answer questions, and assist with various tasks. Anthropic's Claude is also known for strong reasoning capabilities and ethical considerations. It excels in tasks requiring careful analysis and nuanced understanding. Chatbot strengths include specialization and focus, which also means that chatbots can be designed for very specific tasks or domains. They're highly efficient for narrow, well-defined purposes, like answering facts about a particular course. They're simple and they're efficient. They often require less computational power than a full-scale LLM or an AI assistant. They can provide quick, straightforward responses without unnecessary complexity. They have controlled responses, which make them easier to ensure consistent, accurate responses for sensitive or critical information. There's a reduced risk of generating inappropriate or off-topic content. They have user-friendly interfaces, which are typically designed with intuitive, conversation-like interfaces, and they can guide users through specific processes or decision trees. They also have integration capabilities. It's often easier to integrate into existing websites or applications. They can be seamlessly incorporated into specific workflows or customer service processes. And they also have lower resource requirements. They can run on less powerful hardware, making them more accessible for smaller institutions or projects. They're often more cost-effective for specific limited use cases. They're also predictable and reliable. Their behavior is more predictable, especially for rule-based chatbots. They're easier to test and validate responses for all possible inputs, and there are privacy considerations. They can be designed to handle interactions without storing or learning from user data. So they can be useful for scenarios where data privacy is a critical concern. To compare LLMs, AI assistants, and chatbots, LLMs are the most complex and versatile. They require significant computational resources and can perform a wide range of language tasks. AI assistants are built on top of LLMs with additional features. They combine LLM capabilities with specialized functions and integrations. They're designed for more interactive and task-oriented use cases. Chatbots range from simple to complex. They can be rule-based or AI-powered. More advanced chatbots may use large language models, but many use simpler natural language processing techniques. Regarding purpose and functionality, large language models are general purpose large language processing and generators. They're used as a foundation for various AI applications. They're not designed for direct user interaction in their base form. AI assistants are designed for interactive, multi-turn conversations. They can perform complex tasks and access external information. They often have a broad knowledge base and can handle diverse queries. Chatbots are primarily used for simulating conversation and handling user queries. They're often specialized for specific domains or tasks. They can range from simple facts to more complex conversational agents. Now we're going to move on to a simple but important concept: multimodality. Multimodality in AI refers to the capability of artificial intelligence systems to process, understand, and generate information across multiple types of data, or modalities. These modalities typically include text, images, audio, video, and numerical data. Next, we're moving on to the very important concepts of tokens and context windows. In the context of natural language processing and large language models, tokens are the basic units of text that the model processes. They can be words, parts of words, subwords, or individual characters, depending on the tokenization method used. Tokenization is the process of converting raw text into these processable units. The context window refers to the amount of text measured in tokens that an AI model can consider at one time when processing or generating text. It represents the memory of the model for a given task. So, for example, if you're using a large language model, in a given chat, there is a limit to the context window where the model may forget your original parameters at the beginning of the chat, so it needs to be reminded. Different models have different limits to their context window. There are different limits for the forward-facing models, which are those that you pay a subscription for, and the API, which is often used by developers as they pay as they go based on the amount of tokens they use. For example, with Gemini 1.5 Pro, for its forward-facing model, it has up to 1 million token limit. Its API has up to 2 million tokens via Google AI Studio and Google Vertex AI. ChatGPT 4.0, which is from OpenAI, its forward-facing model varies, but it's usually up to 32,768 tokens for some versions. API has 128,000 tokens. For Claude from Anthropic, its front-facing API and its API have a capacity of 200,000 tokens. And now we move on to prompt engineering. Prompt engineering is the practice of designing and refining input prompts to AI models, particularly large language models, to elicit desired outputs. It involves crafting precise and effective instructions or queries that guide the AI's response, taking into account the model's capabilities and limitations. Some key techniques are to give clear instructions, providing explicit directions for the desired output. Context setting, which is giving background information before asking a question. Few-shot learning, which is providing examples of desired outputs before the main task. Or role-playing, which is assigning a specific role or persona to the AI. Some constraints and format specifications are important to consider because we have to define limits or structures for the output. Some more advanced concepts are chain of thought prompting, which is encouraging the AI to show its reasoning process, or recursive prompting, which is using AI outputs as inputs for subsequent prompts. There's also adversarial prompting, which is testing the model's robustness with challenging or edge case inputs. The relevance to the humanities is that effective prompt engineering can help humanities scholars guide AI tools to produce more relevant and nuanced analyses of texts, to generate content in specific literary styles, or provide more accurate historical context. It's a crucial skill for leveraging AI in research and teaching within the humanities. Now we're going to discuss the difference between forward-facing and API models. They're basically how you can access different LLM models. The forward-facing interface is typically a user-friendly web interface or application where individuals can directly interact with the LLM. Users can input prompts, ask questions, or request tasks without needing to write code or understand API integration. This interface is designed for ease of use and immediate access to the model's capabilities. Forward-facing products are ready-to-use AI applications. The technical skill needed to use them are minimal. The flexibility allows for limited customization. And typically, they're paid through subscription or freemium models. Some examples include ChatGPT 4.0, Claude 3.5 Sonnet, and Gemini 1.5 Flash. For the humanities, language translation, writing assistance, and text summarization are some of the possibilities through a forward-facing model. Simultaneously, these LLMs often provide API, or Application Programming Interface, access, allowing developers and organizations to integrate the model's capabilities into their own applications, products, or services. API access enables programmatic interactions with the LLM, offering more control, customization, and the ability to process requests at scale. So the basic definition is that it allows for protocols for integrating AI into applications. It requires programming knowledge in the most cases. It's highly customizable, and it has use-based pricing based on the number of input and output tokens. Some examples include OpenAI ChatGPT 4.0, Claude 3.5 Sonnet, Gemini 1.5 Pro, just like we saw with some of the forward-facing models. For humanities use cases, APIs can be used to create custom text analysis tools, research platform integrations as well. So APIs offer more customization but require technical skills, while forward-facing products provide immediate usability for non-technical users. Now we're going to talk about open source and closed source LLMs. Open source LLMs have their source code and model weights publicly available, allowing for examination, modification, and free use. Their transparency is high because the code can be examined. They're highly customizable. The support is community-driven, and the cost is often free or low cost. Several examples include GPT-J, an open source language model, or Meta's Llama. Humanities applications are vast. They can be used for digital humanities tools, collaborative AI models for language processing, and for more. Closed source LLMs are proprietary models where the source code and exact model parameters are not publicly accessible. Therefore, the transparency is limited, as is the customization. But there is professional support. The cost is usually through a paid service. Examples are IBM Watson, Palantir, and an LLM example is ChatGPT 4.0, OpenAI's proprietary model. OpenAI used to be an open source model, but switched to a cost-based closed option. Some humanities applications for a closed source LLM are specialized software for art authentication and manuscript analysis. Therefore, open source promotes transparency and customization, while closed source often offers more polished, supported solutions. In the context of LLMs, open source models allow for greater scrutiny and adaptation, while closed source models may offer more advanced capabilities, but with less transparency. As we wrap up this episode on key vocabulary in generative AI, I hope you're feeling more confident in your understanding of these important concepts. We've covered a lot of ground, from the foundational ideas of neural networks and natural language processing to the nuances of large language models, AI assistants, and chatbots. Remember, understanding these terms is more than just learning a new vocabulary. is about gaining the tools to critically engage with AI technologies in our humanities work. Whether you're considering using an AI assistant for research, exploring the potential of LLMs in textual analysis, or thinking about the ethical implications of generative AI in your field, this knowledge forms the basis for informed decision-making and innovative applications. As humanities scholars, we bring unique perspectives to the development and use of AI. Our expertise in critical thinking, cultural analysis, and ethical reasoning is crucial as these technologies continue to evolve. By understanding the language of AI, we can better contribute to discussions about its development, application, and impact on society. Thank you for joining me on this journey through the key vocabulary of generative AI. In our next episodes, we'll dive deeper into specific applications of AI in humanities research and teaching. Until then, keep questioning, keep exploring, and keep pushing the boundaries of what's possible in our field. Please like, subscribe, and hit the notifications bell. Also, let me know if you have any suggestions for the UDO outro. See you next time.
No, that's your NLP, generative magic mindset free. Learn the terms, break them down. AI kingdom with the crowd. Connect with me, diving deep. LinkedIn, Insta, where we tweet. AI humanities, find a way. Bridge the gap every day. Connect with me, diving deep. LinkedIn, Insta, where we tweet. AI humanities, find a way. Bridge the gap every day. Digits light up, machine hearts loud. Welcome minds, we make them proud. Code is poetry, lines are fake, and the cycles calculate. Algorithms twist and turn, data patterns, sparks burn. Human touch and robot realm, hybrid future, take the helm. Digits light up, machine hearts loud. World of lights, we make them proud. Code is poetry, lines is fate, and the cycles calculate. Algorithms twist and turn, data patterns, sparks burn. Human touch and robot realm, hybrid future, take the helm. Neon dreams in darkest night, breathing life in ones and zeros, rises gods of tides.